Hi, once again, welcome to Varenia's Photon Online Educational Academy. This is Guntuka Srinivas. This is a free educational channel meant for 8th class standard to the 12th class standard students. In the previous session, we have seen some numerical problems related to distance and displacement. Let us see some more problems related to those concepts. Let me take up the first problem, the first one. Find out distance and displacement in the given figure. A man walks towards east 2 meters, then turns right angles, walks towards north 3 meters, towards north 3 meters. Yeah, this was the problem. In this problem, we need to find out the distance as well as distance. And what is the concept here provided to us? A man walks towards east 2 meters, then turns right angles, walks towards north 3 meters. This is the given. Clear? Let us take up the problem. Observe. Suppose, let us say man is present here. General directions, I quote. This is east, this is west, this is north, this is south. East, west, north, upward north, and down south. Yeah. Now, what it says, a man, initially, let us say, is present at A, walks towards east. East is this direction, towards east. How many meters? 2 meters he walks. Let's say B. And initially at A, walks towards east in this direction up to B, 2 meters. Then walks towards north. North is upward, right angles, upward. Walks 3 meters. Let us say 3. This is 3 meters. B to C towards upward north 3 meters. Now, in this case, he's saying that distance as well as displacement. Now, observe. This is initial point towards east up to B, 2 meters. He's walking. Then B to C towards up north 3 meters. This is the final point. Clear? Now, what is the distance covered? Distance covered is, first one is asking distance. So distance Distance is nothing but path length traveled by the man. AB, A to B and B to C. Path length. So AB plus distance. So this becomes how much? This is AB 2 meters plus 3 meters BC. 5 meters is total distance. 5 meter is total distance. Yeah. In the second thing, it requires displacement. Displacement. What is the meaning of displacement? Displacement is nothing but the shortest distance between initial point and final position. Initial position and final position. So this is the initial. A is initial and C is final. Shortest distance, or simply the straight line, the length of the straight line joining the initial point and final. Clear? Now here I join this by means of a straight line. This is the straight line completely joining initial and final positions. So AC is the displacement. Clear? AC is displacement. Now observe, this is a right angle triangle. Simple mathematics says apply the Pythagoras theorem. So AC square is equal to base square plus height square. So AB square plus BC square means here 2 square plus 3 square. 2 square plus 3 square. So coming here, AC square is equal to 4 plus 9, 13. So AC is root 13 meters. This is the displacement. Clear? Now observe. What is this is the magnitude. This is magnitude. What is the direction? Direction is from always initial position to final position. So A to C. Direction. Direction here I clearly write. Direction of displacement. Direction of displacement. A to C. A to C. Clear? A to C. AC bar is displacement. AC bar is displacement. Displacement. Is it clear? It's a simple concept. Okay. Now, this problem we have solved simply by means of simple mathematics. Okay. Let us solve the same problem by means of vectors, using the vectors. Observe. This is the direction, as I told, east, west, north, and south. That's the direction. What it says, manage at the initial position, moving up to the 2 meters towards east, up to B. Then moving up. Clear? So up to the 3 meters, up to C. This is the given problem. Clear? Given problem. Now, distance is same. Distance is path length. So distance is a scalar quantity. So hence, no vector is involved in distance. Hence, distance is same. So distance, if I say distance is scalar quantity. I write clearly. Distance is a scalar quantity. Clear? So hence no direction. So simply path length AB plus BC. So AB plus BC. That is 2 meters plus 3 meters. 2 plus 3. 5 meters is the distance. 5 meters is the distance. Clear? But Observe here. Displacement is a vector. Displacement is a vector quantity. So it is having both magnitude as well as direction. It is having both magnitude as well as direction. Let us find out the displacement by means of vectors. By means of vectors. Observe. This is initial point A, final, that is the B is A. Man is at A, walking towards B, east 2 meters, up 3 meters. Up 3 meters. This is the points. Clear? Now, we are using vectors. We are using by means of vectors. Vectors are used. Vectors are used. Clear? Now, observe, when you are using the vectors, this is the general direction. This is x-axis. This is y-axis. This is z-axis. This is r-axis. So the unit vector along x-axis is I cap. The unit vector along y-axis j cap. The unit vector along z-axis k cap. Clear? These are all positive side. Positive side of the x-axis is I cap. Okay, if I want the unit vector along the negative side of the x-axis, this is dotted lines are showing negative side of x-axis, x bar is negative side of the x-axis, then this becomes minus I cap. Direction is changed. Similarly, if I need negative side of the y-axis, dotted lines showing negative side of the y-axis, y bar, positive side of the y-axis unit vector is j cap. Negative side of the y-axis, it is minus, reverse direction. Direction change is minus, magnitude is same, so j cap. Clear? Similarly, if I need unit vector along negative side of z-axis, dotted line show z bar, negative side of the z-axis, then positive side of z-axis k bar, negative side of the z-axis minus k cap. That means towards positive x-axis I bar, towards negative x-axis I minus I cap, towards positive y-axis j cap plus sign, towards negative y-axis minus sign, minus j cap, towards positive z-axis k cap, and towards negative z-axis minus k cap. Negative means minus. These are all I, j, k are the unit vectors. I, j, k are the unit vectors. Here I clearly write where I cap, j cap, k cap are unit vectors along positive x, positive y, positive z axis. Clear? You want to take up the negative side, minus I cap, minus j cap, minus k cap. Clear? Okay. Now observe carefully. Observe carefully. Okay. Now here, if I want to use the notations, this is initial point A, 2 meters walking towards east up to B, then right angle turning up to B, 3 meters walking. Now observe. The person, whenever you want to put up a vector form is put up. Let us say example, if I want a bar vector along positive x-axis, then magnitude of this A, simple A, yes, simply A stand without bar is magnitude I in unit vector along that direction. Unit vector along that direction. N cap. This is the vector notation. In any direction. Clear? Previous class we have seen that. Suppose if I want to write towards positive x-axis, towards general notation, I am saying that A bar is magnitude of that A along x-axis, AX component or magnitude along x-axis, I cap plus magnitude of this A or component along y-axis into J cap plus magnitude of A along z-axis component along z-axis into K cap. This is a general vector notation. Clear? Anything? Okay. Now, observe. We are taking the sign convention was what? East, west, north, south. So towards east, right side, we are assuming positive direction. Towards up, towards north, we are assuming positive direction. Similarly, towards west, automatically negative. Towards south, automatically negative. East side positive, north side positive. East side rightward positive, upward positive. Remaining the negative side. Yeah, no observe. For this is starting from where? Initial point A, man is walking towards east. Walking east towards east. Towards east, direction is from where to where? A to B, towards east. East is positive, I have taken. That is towards x-axis, positive x-axis. Yeah. Now, what is the vector form? AB vector, AB bar vector. I can write AB bar vector as magnitude of this AB. How much magnitude of AB? 2 meters. 2 into towards positive x-axis. What is the unit vector? I cap. That's all. This is AB bar vector. Yeah. Similarly, I need this after reaching east up to B. E is moving, right angle is upward. E is moving, right angle is upward. Upward sign is positive, means towards positive y-axis is moving. Okay, BC vector, I need BC bar. I need what is the magnitude? Because general form is magnitude of that vector into unit vector along that direction. So what is the magnitude of BC? 3. It is towards which? Up. Up is what? North side to up, positive. And positive y-axis, what is the unit vector? J cap. So J. This is BC bar, right? BC bar. Clear? So first, you notify the vector forms by taking the direction eastward positive, upward positive. Positive x-axis, I cap, positive y-axis, J cap, unit vector. General notation is any vector can be written as magnitude of it. Magnitude means length of that vector into unit vector along that direction. If it is positive, plus sign. If it is negative, reverse downside. Okay? Right. We see the form. Now, let us put these things in a simple manner. This is A, initial point. This is B. This is C. Now, AB bar. Just now we have noted 2 I cap. Similarly, BC bar is 3 J cap. And direction is from where to where? A to B. Direction is from where to where? The direction is from A to B. Tail and head. Again, here direction is B to C. Tail and head. Now, what is the displacement says? Displacement is the line joining the initial and final positions. So AC is the displacement. AC is the line joining initial and final positions, or the shortest distance between the initial and final position. AC bar is the displacement. Clear? So simply making use of triangle law. AB bar, tail to head. Again, BC bar, tail to head. AB bar plus BC bar, tail to head. Again, tail to head. Then, by making use of triangle law, the resultant is what? Summation. The tail of the first vector to the head of the last vector. Join this. This is the displacement. Direction is from A to C. Direction is from A to C. Clear? So AC bar is AB bar plus BC bar. So vector is written as 2I cap plus 3J cap. Clear? That is AC bar. This AC is nothing but line joining initial to final AC bar. This is displacement. This is displacement. Clear? Displacement in the vector form. Displacement in the vector form. Here I clearly write displacement in vector form. Now, what is the magnitude? We require the magnitude of AC bar, modulus of this magnitude, square root of the coefficient of I cap square plus coefficient of J cap square, 2 square plus 3 square, so root 13. So this is magnitude of displacement. Okay, direction is always from A to C. Clear? Simple concept by means of the vectors. By using general mathematics, you can calculate simply the vector form also. The displacement is a vector. Okay. So this is how we have calculated the simple displacement. Let us take up the second problem. The second problem here shows a man walks 2 meters towards south, then turns 3 meters east, then turns right angles, 2 meters north, and again 3 meters towards east, Then 2 meters, 2 meters towards, towards, towards south, towards south, right angles, towards south, right angles. Clear? Observe carefully the problem. A man is walking 2 meters towards south. First towards south. Then 3 meters towards east. Then turning right angles 2 meters north side. Clear? First south, then east, then north, and again east, and again 3 meters east, then again 2 meters south. How many turns? South, east, north, east, again south. Okay. In this case, he is asking two things. First one, distance traveled. Distance traveled. Number two, displacement. Clear? So two things he is asking. First is distance, second is displacement. Yeah, 2 meters, 3 meters, 2 meters again 3 meters, again 2 meters. Okay, so here, let us solve this problem. Man, suppose that general directions here I am showing. General directions. This is east, this is west, north, and south. These are the general directions. Okay, now what he says, he's saying that first, let us say that man is present here. Man is present here at A. He is moving towards south. South is down. So towards south. How many meters? 2 meters. To be. Then again towards east. 3 meters. Towards east, 3 meters. This is 6 meters. Again is going towards north 2 meters. North 2 meters. D. Again is going east 3 meters. East 3 meters. We again is going towards south, again 2 meters. Observe. So the man is going, his initial point is at A, he is moving towards south, down. That is down. Here I am showing the direction towards south, A to B, 2 meters. Again from B to C towards east, 3 meters. Again C to D towards north, 2 meters. Again D to E towards east, 3 meters. Again E to, let us say, this is some F. E to F, again coming here, E to F, south 2 meters. Okay, now in this case, he is asked two things. First one, he needs displacement. So first one he needs distance. So distance is what? Simple. Path length. A to B, B to C, C to D, D to E, E to F. Simple path length. Addition. Because scalar quantity, no direction, no sign. So simply AB path plus BC plus CD plus DE plus EF. EF. So that is 2 meters, 3 meters, again 2 meters CD, DE 3 meters plus EF 2, 3, 2, 3, 2, 3, 2, 3. 5 plus 5, 10 plus 12 meters. Total distance traveled is 12 meters. Clear? Total distance traveled is 12 meters. Now, what is the displacement? It requires displacement also. What is the simple concept of displacement? Displacement is shortest distance from initial point to the final point. Final is F, initial is A. So straight line joining these two. This is the straight line joining these two. This is the displacement. The length of the straight line joining initial position to final position. Yeah. Observe simple mathematics we can make use. Okay. Now, if DE is 3 meters, if I draw a parallel line, DE is 3 meters, then CF is also 3 meters. Because this is 2 parallel, this is 2 parallel, this is 2 parallel. And this is 3, then this is also 3. So DE is equal to CF. This is 3, means this is 3. Now observe in this case. ABF. ABF is a right angle. ABF is a right angle triangle. And in the right angle triangle, height is AB and base is BF. BF. So BF is how much? Here to here. 3 meters plus 3 meters. 6 meters is BF. AB is how much? 2 meters. We require a hypotenuse AF. That is displacement. So simply in this triangle, if I apply Pythagoras theorem, AF square is equal to base square. Base is BF square plus height AB square. Clear? So ABF triangle. ABF triangle. ABF triangle. So here I am putting A, E, F triangle. Clear? This is 2 meters. This is 6 meters BF. And this is the straight line joining the AF. This is displacement. So right angle triangle. So AF square, Pythagoras theorem applying. Base square, BF square plus height is BA square. Clear? Now this becomes 6 square plus 2 square. So 36 plus 4, 40. So AF is square root of 40. Square root of 40 meters. That means further simplification. 4 root is 2. 4 into 10 we can write 2 root 10 meters. 2 root 10. This is the displacement. AF is bar because A to B direction is from A to B, initial position to the final position. F bar is 2 and 10 meters. This is displacement. This simple mathematical concept. Okay. Now this problem can also be solved by means of vectors, using the vectors. Let us see the vectors. Remember this magnitude. Direction is A to F, magnitude is this. Same magnitude, whether we get or not, let us check. Okay. So, same problem. Same problem can also be solved by vectors. Making use of the vectors. Now observe, this was given. This was initial point A to B, B to C, C to D, D to E, again E to F. So A, B, C, D, E, F. Clear? Now directions. A to B, B to C, C to D, D to E, E to F. Magnitudes. What he has quoted magnitudes? This is 2 meters, 3 meters, 2 meters. This is 3 meters. Again the 2 meters. Yeah. Now observe. Now I want to put up the in the vector. A is initial point. A to B. AB bar vector. So AB bar vector. AB bar vector. Bar A to B. Tail to head AB. What is the magnitude? Magnitude is 2 meters. So and direction A to B. Downward direction. Downward is negative. Towards negative axis. What is the unit vector? J cap. Unit vector is J cap. But minus sign. Why minus? Because down. Okay. Next. BC vector. BC bar. Tail to head BC bar. BC bar towards positive x-axis. What is the magnitude? 3. The vector from 3 magnitude. Towards positive, unit vector is towards x-axis I. Towards positive, so plus 1. So plus. Clear? Now again, CD vector. CD vector. CD vector, CD bar. C is tail, D is head. Upward. Upward is positive. Towards positive y-axis. What is the magnitude? 2 meters. 2 meters magnitude. Upward positive. Unit vector is J bar. J cap. Towards positive, so plus sign. Clear? Similarly, D vector. D is tail, E is head. D vector. Tail to head. Towards positive x-axis. That is magnitude 3 meters. 3. Positive x-axis unit vector I cap. Positive. Okay. Again, the EF vector tail to head. EF vector tail to head. F bar. What is the magnitude? 2. Downward direction towards negative y-axis down. So J cap is unit vector but negative. Negative towards downward direction. Negative sign. So we have represented AB bar, BC bar, CD bar, D bar, EF bar in the form of the vectors. How to represent a vector? Magnitude into its unit vector. It is positive axis, positive sign. If it is negative axis toward negative axis, negative sign. Clear? These are the vectorial form. Okay? Vectorial. Understood? Now, observe. Suppose, let us say that if A bar is one initial point is here, let us say A bar is here to here, A bar is one vector. Then here to here is B bar is another vector. Then here to here is C bar is another vector. Clear? Tail to head, tail to head, tail to head. Then what is the resultant summation from the initial point to the final point? Observe. A bar, tail to head, B bar, tail to head, C bar, tail to head. Then the resultant is the tail from the initial point to the head, to the final point. This is the result. Direction, let us say capital A, capital B. Okay, that is the concept. Okay, same I am applying, simple addition I am applying in this case also. This is okay. Now observe. Now this is the point A, this is B, this is C, this is D, this is E, this is F. This is F. Yes, this is F. Now directions, you know, A to B, B to C, C to D, D to E, E to F. Clear? Now tail to head, tail to head, tail to head, tail to head, tail to head. Okay, final sum is what? From the initial point to the final point joining. This is the sum. Direction is A to F. Clear? Now sum of all these, that is AC bar, AC bar, AF bar, initial point A, F is final point, AF bar is AB bar, A to B, plus BC bar, plus CD bar, plus DE bar, plus EF bar. Initial point tail to the final point H. Final point H. This is the sum of the vector. Okay, that's AF is nothing but the displacement. This AF itself is the displacement. AF is displacement. Clear? Now, what are those things? Just let us add these. AB. Just now calculate the vector downside minus 2 j bar, j cap. BC 3 I cap, positive x axis. Up again positive 2 j cap, then positive 3 I cap. Again down negative 2 j cap. Yeah. Okay. Now observe. Positive 2j, negative 2j cancels. So 3i plus 3i, 6 cap minus 2j cap. AF bar vector form is this. AF bar vector. This is the displacement vector. This is the displacement vector. Now, we require the magnitude of the displacement vector. So AF bar is displacement vector, which is 6 I cap minus 2 j cap in the vector. Magnitude of the displacement vector, modulus of this is square root of coefficient of I cap square plus coefficient of this minus 2 square. So this becomes clear. Now here observe, minus stands for only direction. This is directly you can write 2 square also. This is directly you can write the 2 square. 2 square. So 36 plus 4 is root 40. So root 40 is 2 root 10. F bar is 2 root 10 meters. This is magnitude. Clear? Which is same as that of the previous simple mathematics. Also, we got the same magnitude. Even if you use vector also, same thing. Magnitude of displacement. It's modulus. Direction. You need the direction. Direction. From where to where? Direction of displacement vector F bar is from A to yeah, initial position to final. Clear? That means, observe, you can solve a simple mathematical question by means of two methods. First is simple mathematics you can use. The other is, in the simple mathematics, you can make use of geometry of the figure. Then you can calculate joining straight line from initial to final. Then easily you can find out the displacement. Whereas in the other method, you can make use of the vectors also. Each length is denoted by vector form. Then sum up them to get the displacement, because displacement is initial to final position shortest distance. Clear? So same problem can also be solved by simple geometry of figure, by simple mathematics, and also by means of vector notations. Clear? Hope you have understood clearly. So if you like the channel, please share it, subscribe it, encourage the channel. Thank you very much for patiently.